You thought you were done, but not really. So I'm going to go through this, and my first one is going to be fairly imprecise. And then I'm going to redo these examples again and try to make them really precise. So now I'm going to try to determine the approximate value of the square root of 0.7. The square root of 0.7, well, 0.7, I'm going to put my benchmarks. There it is. It's probably somewhere between the square root of 0 and the square root of 1. 0.7 isn't a perfect square, but what I can do is I can let my radicand, that number underneath the radical or square root sign, be an integer, a whole number. And it makes it quite easy. So I know that the square root of 0.7 is likely closer to the square root of 1. The square root of 0 is 0. The square root of 1 is 1. The square root of 0.7, I might even say it's approximately 0.8. It's approximately 0.7. That's what would be my guess. Okay? But I can do better than that. But allow me to go through these three examples first. The square root of 0.12. Well, the square root of 0.12, I'm going to pick out my perfect squares that are close by. Well, the square root of 0 and the square root of 1. 0.12 is the number between 0 and 1. What I notice is 0.21 is much closer to the square root of 0 than it is to the square root of 1. So maybe I suspect that the square root of 0.21 might be around a quarter, or it might be 0.2. All of these are valid. And in fact, 0.1 would be valid, 0.2, 0.3, 0.4. These all might be valid. These are good guesses for it. And that's what we're trying to do, just an approximate value. Now, this seems oddly specific, doesn't it? The square root of 7.21. So the square root of 7.21, I'm going to try to pick my perfect squares here. So the perfect square that is just below 7.21 is 4. Square root just above 7.21 is 9. And the square root of 4 is 2. The square root of 9 is 3. So the square root of 7.21 is probably closer to the square root of 9 than it is to the square root of 4, simply because the radicand is a lot closer to 9. I don't know, 2.7. All right, I think we got a flavor for this. Okay, I am just going to erase this one, and I'm going to try to make this really, really specific. Now, you have to be pretty clever to think of these. So maybe I want to think of 0.21 not as 0.21, but as 21 over 100. Make sure that my radical goes all the way underneath there. There, bigs. So, and then I think of the perfect square, if I can think of a perfect square just above 21 hundredths. And in fact, I'm thinking of 25 hundredths. Now remember, both the numerator and denominator need to be perfect squares. There. Well, I would call this maybe the advanced class of approximating square roots. Now I'm thinking of the perfect square just below 21 hundredths, so the square root of, and then I go reach out and I think about what is the perfect square? Oh, I know. The closest perfect square, I think, is 16 over 100. And what I see is that these both are perfect squares. And I can take the square root of that. The square root of 16 over 100 is 4 over 10. The square root of 25 over 100 is 5 over 10. And really, this is 0.4 and 0.5. Wow, this is a pretty good estimate. And in fact, 21, if I take a look at my radicands now, 21 hundredths is almost equal distance between these two. So I'm just going to go out on a very, very far limb. I'm going to start impressing people back at home that the approximation is probably likely between halfway between these two numbers. And then the number that is halfway between these two, I would think would be 0.45. If you want, take a look in your calculator. I'm pretty sure it's accurate. Okay. All right, friends. This one could be a little bit tough. Now, remember, this is the key word in all of this. Estimate. What is a right angle triangle doing in here? I don't know. Let's find out. Just recall that a squared plus b squared is equal to c squared. That where c squared is your hypotenuse. Now, it doesn't matter which side you call A and which side you call B, but we can estimate this. Did you know that A squared plus B squared is equal to C squared? And C squared is my hypotenuse. A squared, well, I'm not going to put 2.1. That's really too specific. This is just an estimate. I'm just going to put 2. 2 squared, because A is 2.1 plus B is 5.2. So I'm just going to put plus, instead of 5.2, I'm going to put 5 squared. Did you know that's equal to C squared? So I'm just going to continue my work here. 2 squared is 4 plus 5 squared is 25, and that's equal to C squared. Now I'm going to add 4 and 25, and that's 29. 29 is equal to C squared. So this is where it kind of gets a little bit out of reach. So I'm looking for C squared is equal to 29. If I take the square root of both sides, what I'm left with is C on the left-hand side. The right-hand side is the square root of 29. Now, I don't know the square root of 29, but I can easily benchmark it. So I know that C is equal to the square root of 29, has to be between the square root of 25, which is 5, and the square root of 36, which is 6. So I'm going to estimate that C is approximately 5.5, right exactly in the middle.